Hello again. I finally rewrote the this the pick and six game from scratch. Instead of using OpenGL, I'm using Direct3D 11. So yeah, um, I have both projects open at the same time. This is the OpenGL one. As you can see, nothing has changed in this code base at all. It's still the same. It does roughly the same thing. Let's run it real fast. There we go. It's just picking sticks. And if we look at the task manager, where are you? Huh, it's using less memory than it's supposed to be doing. Interesting. But it's still running at like 38, at least 37 megs of memory being used on this. But nonetheless, it runs okay. So let's exit it real quick. This on the right version on the right is the Direct3D code. So let's do some comparisons with the code base. How OpenGL typically stores classes and that sort of stuff. They use a kind of an int index, and the driver itself basically manages the class instance of it. It makes it easy for for you to do OpenGL programming with C, but with Direct3D, you kind of had to use C++ with that because they use COM objects, which kind of act like C++ classes. It does a little bit more than C++ classes, but I'm not going to get into that because it would be out of scope. That's one significant difference. The other difference is how much code it requires to actually initialize the graphics pipeline. In the OpenGL version, it's still long, but it's not like as long as Direct3D because it the driver itself pretty much does most of the hard work for you. But in Direct3D 11, you have to do some additional stuff. At least unlike Vulkan, you don't have to deal with video card memory management, so you don't have to worry about that. But it's a lot more than OpenGL. And how to change states in Direct3D, unlike OpenGL, where you can just change a state using the GL disable or GL enable functions. You have to basically create a structure and pass data between it. So you have to create multiple structures and COM objects to basically change the state of how the renderer works. So let's walk through it. The first thing you might have noticed is that with the DX11 code is that there's, like I stated before, there's a lot of structures and how it handles the swap chain, where in the OpenGL version you don't have to worry about the swap chain because SDL handles that for you in a nice manner. Excuse me. The other difference is how it handles contacts and devices. If you want to create an object with it, you use the device interface to create, say, shaders or textures and that sort of stuff. Where OpenGL, you just use their function, kind of functions from their interface. Now, the other cool thing about OpenGL versus Direct3D is the fact that you can load up shaders in a binary format, where in OpenGL, unless you're using 4.5, which I ran into issues using binary shaders with it, you can just load them up in the binary format. Alright, sorry about that. My brother needed an assistant with something. Um, okay, where was I? Yeah, yeah. The thing about OpenGL is that without the new version of it, which is 4.5, you can't use binary shaders. But Direct3D 11 allows it. And the other cool feature is that with Visual Studios, you can compile HLSL shaders, which is pretty cool. Let's go into properties on this real quick. You can do some interesting things, like in general, you can set the type of shader it is, use whatever shader model you want, which is 5.0 for this project, and direct the output file or the compiled shader to whatever directory you want, which for my purposes it's in the same location as the GLSL shaders. Okay, now if you remember what I stated about vertex arrays, well, in Direct3D, vertex arrays in this is input elements or input layouts. Basically, an input layout is how you segment your data within the pipeline. And for my purpose, I'm only dealing with positions and text coordinates. So if you look through this, position is basically the vertices, and I'm using their input slot at the zero input slot. As for text chords, I'm using the next slot over to kind of simulate how OpenGL handles it. There is a limit to this. You can have a limit up to like 15 slots according to their documentation. But yeah, I think the same limit exists in OpenGL, but it's just not applied. Moving on. Now down here, I did the same thing with the pixel shader as I did with the vertex shader. Pixel shader is essentially just a fragment shader from OpenGL. One major difference is that in Direct3D 11, it doesn't have the concept of uniforms. You have to use what is known as a constant buffer, and that's how I'm passing matrices to it. I'm using the same kind of language as OpenGL. So let's do a little shader comparison. I have both shaders in here. Both loaded. Yeah, basically I'm using the same kind of variable names for it. Same with the fragment shader. Let's do a comparison of both of them real quick. Not that one, I want you, and I want to open. There we go. I'm doing roughly the same thing in each shader base. The only difference is that I had to use constant buffers instead of using straight uniforms. OpenGL has something similar to constant buffers, which are uniform buffer objects. I'm not using them in this project because I'm not managing multiple shaders, so I didn't really worry about it as much. So I decided to just make a uniform, just be done with it. One major difference between OpenGL and Direct3D is that you don't have to worry about these like variable modifier things. You can simply output information directly to the shader in GLSL. I do in fact like that because I'm far more used to how GLSL works compared to HLSL. There are some similarities. Like for one, is that you can use the discard word to discard your fragment, which actually technically the fragment word makes more sense in the context of shading. Pixels basically means that you're dealing with pixels directly, but that's far from the truth. It's more of a fragment because you can turn it off and on if you want to. That's one piece of terminology hopefully Microsoft will fix one of these days and just use fragment, which makes more sense. Um, One major difference, if you look at this, is that Texture 2D, you can't get access to it direct. You can get access to it, but you also need a sampler state, which I'll get into that when we get back to the code. The sampler state controls the wrapping and like whatever filter you're using for this. So let's go back to that. All right. So I had to create a constant buffer, which is going to be for this structure up here, which you can actually use DLM with it. So you don't have to worry about whatever matrix library, whatever math library you use. It does the same thing. It's kind of nice, actually. All right, let's continue. So yeah, I had to create a constant buffer first, which stores the matrices in it. Then I did this roughly the same thing as OpenGL. I made some vertex buffers. If you go down here, vertex buffer, it's roughly the same thing. The only difference is it requires a little bit additional code for it. I am using a dynamic one, but you could use just a default one and just upload this mess right here into it using a D3D resource data, but you won't be able to change it unless you're doing it from the GPU side of things. And dang you, there we go. And you can do the same thing with the text core data. So there's a lot of similarities between both APIs. The only one major difference between the two of them is that you have to make a rasterization state, which here I basically tell Direct3D that I want it solid. I'm not going to do any calling because there's no point. We're not doing any 3D. Then I set the state to the rasterizer. And the other thing, with release, I'm doing roughly the same thing. I'm just releasing all the COM objects, and OpenGL, I'm releasing all objects with it as well. Now let's continue. The viewport, similar to everything in Direct3D, is stored as a structure. One interesting fact about these is that the GL viewport actually stores all their information in integers, where the viewport in Direct3D, they store it as floats. Kind of different. And not just that, they also store kind of def data as well, which is pretty interesting. As you can see, the clear state's a little bit more complicated in Direct3D. It's because you have to set up all states using the context object, where in the OpenGL one, the only thing I had to do was just set the clear color and then clear the color buffer on the back end, and then just using the program. In the present method or function, because you swap the window or buffers with SDL, which I'm doing it up here, because where are you? Right there. This is the equivalent to this method. Basically, you're swapping the internal swap chain in OpenGL with the one that you're rendering to prevent tearing. But with Direct3D, you have to do it with their kind of system. All right, let's move on. Let's go to excuse me. Now, for setting up the projection, view, matrices, and model, because I'm using uniforms, you just have to set the uniforms. If I was using UBO, it would be similar to the Direct3D example, because you would have to update the UBO, which basically you're just mapping it up here. It's a little easier with Direct3D, you just have to bind the buffer to do this, so it'll be 3 lines of code instead of 4, because you need a structure for Direct3D 11. But at the same time, you're doing roughly the same thing if I was using UBOs. However, I'm not using UBOs here, I'm just using straight uniforms, so that's why it's slightly shorter. And you have to update it each time you change this. I didn't have any slowdown from doing this, so I'm not too worried. And the final thing is the draw method. Because I'm setting up the input interface before this, this is actually way simpler than this one in some ways. As you can see, I have to bind the vertex array, a vertex array, to bind the buffers to whatever attributes that I'm sending information to. Where in Direct3D, I'm doing roughly the same thing, but I'm sending it to whatever input slot that's available to it. You can, in Direct3D, it's easier to do like take an entire structure and passing it to it. It's a little bit more difficult to do that in OpenGL because you have to do some fun stuff with void pointers in this little slot. But in Direct3D 11, it's a little harder to do stuff that you could do easily in OpenGL, vice versa. Okay, moving on. And for the draw raise function, the equivalent is using these two function or methods together. They separate what topology you're using for like triangles, lines, and that sort of stuff in Direct3D, and then you then draw it. Where in OpenGL they combine that. That's one major difference. Okay, now with texturing, like every other Direct3D object, you have to use a structure to pass information to it. And for this one, one issue is that I had to it has a limit that I discovered. You have to add in a there's no format for this, so you can't have like a 3 kind of component color part of your texture. You have to have a 4th component for alpha channels. So I had to basically redo the background image because it didn't have an alpha channel. So as you can see, it does roughly the same thing. You're using STL to get the image information, and then you update in OpenGL you're generating the ID, which is creating an object, and then you upload the information using the geo text image 2D, where in Direct3D you're doing the same thing. You create the texture object using the create texture 2D object, then you update the resource using update subresource, which uploads the pixels. As for the rest of it, in order to get access to the texture in the shader code, you have to make a shader resource, which essentially basically kind of wraps around the texture in a pretty smart way. And then to update the sampler object, which is roughly what these two functions are doing, this is setting the min and mag filter to nearest. In OpenGL, that would be a point filter. And I'm also setting up the addresses to wrap. Alright, binding. Because you have two objects you're dealing with in OpenGL, you have to use these two functions. The nice thing about Direct3D is that you can specify whatever kind of text unit with these functions. Like I'm setting it to 0, which is text unit 0. In OpenGL, you would have to use the geoactive texture to do this roughly the same thing and pass it texture 0. And then you have to bind the texture to the current textile. Where here, you're doing it all at the same time for these two objects. Um, you don't have to unbind anything in OpenGL. You could do it, but why bother? And I'm doing the same thing with getting with night. Okay. Hopefully that explanation wasn't too convoluted. One difference between the OpenGL code versus the Direct3D code is that you don't have to worry about these kind of attributes because you're setting it up with Direct3D. And I'm not using an OpenGL window, so the only thing I needed to do is do a window shown. And I don't have to use glue for this because, well, I'm not using OpenGL. So it makes the window code a little shorter in some ways. And okay, for the moment of truth, let's compare how much memory am I wasting with Direct3D compared to OpenGL. To compile. As you can see, I'm doing some Matrices deconversions, but I don't care. Alright, let's run it. Looks basically the same. It runs pretty smooth, which is awesome. That's what I want to see. Alright, let's look at the memory manager memory. I think I'm using run. As you can see, it's running at 8 megs. 8 megs of system memory. I have a theory for this. I believe it's the AMD drivers that's causing this issue and how it's storing information. Let's run both games real quick. Alright. It runs about the same, regardless of what version you're running. But let's run this one. Yeah, it runs about the same. It's just that the OpenGL version is wasting more memory for some reason. If you look at PNS, it's about 30 megs versus the Direct3D version of it. So let's do some calculation here. Hopefully this is correct way to do calculation. I'm tired. If you divide these two together, there's a 21% change in this code. So if we do, yeah, I haven't done comparisons like this in a while. Yeah, there's a 21% kind of. Yeah, I am doing it correct. What am I thinking? Yeah, if you divide the bigger value, divide the small value from the bigger value, it gives you a percentage between them. So yeah, there's a 22% difference. I could be wrong. I'm kind of tired. I'll just be blunt that yes, the Direct3D version is using less memory than the OpenGL version. The reason why has to do with drivers. The AMD drivers, I believe, if you're running on Windows, the Direct3D drivers are actually way more optimized than the OpenGL ones. That's why there's a significant memory difference between the two of them. And there could be a running difference between the two of them, how fast each version is running. But from my perspective, it doesn't really matter as much. I'm going to assume that this might come up as a problem once you start building something more complicated, like that first-person shooter game I was showing off earlier. There might be a performance advantage to using the Direct3D over using OpenGL's implementation. but I don't see any significant loss in performance wise. It's just wasting more system memory. Yeah, I don't see any performance issues, which is to me is a good thing. It means I'm doing it correctly. Yeah, I think this is it for this video. It's kind of an interesting that Direct3D uses way less memory, and there's no performance drops between the two. So yeah, sorry if this. Hopefully this video didn't bore you. It's just a comparison between the two. And yeah, I hope you all have a great day, and I'll see you in the next video. Y'all take care.